As educators, we know, in the research affirms, that fractions are an exceedingly difficult area of mathematics for students to learn.
Okay, so to figure out 2/5, we made a rectangle with 3 lines vertical and 2 lines horizontal.
How many lines vertical?
5.
Okay, why'd you do 5 and 2 again?
Because in 2/5, there's 2 and 5.
Okay.
So we did that. So then we colored in 5 2 times, and it got 10.
But then it looked like just a whole bunch of numbers like everywhere. But
yeah, but then you start getting a hang of it and you're like, oh, yeah, now I understand. But then you keep asking questions. But what does this mean? And sometimes it gets confusing.
Teams in the Collaborative Action Research Project focused on representing, comparing, and ordering fractions. The research of one team uncovered 3 important models for representing part-whole relationships. In his article in Teaching Children Mathematics, Ted Watanabe highlights the importance of using linear models, area models, and discrete or set models to represent fractions. These samples of student responses were indicative of what we saw in the classroom when we asked students to represent 2/5 and 4/10. The representations used uncover the different meanings that students attribute to fractions. Here, for example, the student representation shows that the student interprets 4/10 as a ratio, 4 to 10. Educators in the project did a lot of thinking about when different representations might help or hinder student thinking. They noticed an overuse of area models, especially circle representations, which introduced errors when dealing with numbers into which circles are not easily partitioned, such as large or odd numbers. Notice that these students have used 2 circles to model 2/5 and 4/10. One is nearly 1/2, while the other is 1/4. Yet they have correctly stated that 2/5 is equivalent to 4/10 at the top of their paper. The use of a number line for representing, comparing, and ordering fractions was examined in multiple classrooms. Teams saw a lot of potential in the number line for representing fractions with greater accuracy and for helping students develop conceptual understanding as well as proportional reasoning.
It's easier with the number lines for...
Yeah, number lines are much easier because
in circles.
You can just use a ruler and you can get exactly what you're looking for.
Circles are also harder because if you have an odd number, like a 5, you wouldn't be able to do it equally. Instead of an even number like 4, you could just do 1, 2, 3, and 4 and just split it easy that way. But a number line is just a line with bars that you can basically, it's just a lot easier.
Comparing requires students to determine which fraction is the largest. Comparing fractions assumes that the 2 fractions have the same whole, so is based in the part-whole meaning of fractions. Students should understand a fraction as a number and use benchmarks such as 0, 1, 1/2, and 3/4 to compare.
We had proved that 2/3 and 8/10 or 8/12 are equivalent. So these two use the same number line. Shown they partitioned it in 2 different ways, so we talked about that. Number line showed these students could take a whole and divide it into both 12 parts and 3 parts to help prove equivalency, and that one whole can be partitioned into different parts.
Ordering fractions requires students to consider the magnitude of the fraction in comparison to whole numbers, benchmark fractions, and the other fractions they've already ordered.
Well, this would be less than this one. This would be right there. This is 0. That's 100, right? That's 1. 0. Wait, what? 45 would be the same as 3/4? Less. It's over 1/4. And not
this is more than, this is like
right there.
So how much is this? No, because this would be 70, 60. Well, we need it bigger. Can you erase that and make it to the end?
Oh, this is a
There are multiple meanings of fractions depending on context. Understanding these different meanings is crucial for teachers to be able to support students. For example, you can distinguish between linear measures, part-whole, part-part, quotient perceptions, and operator perceptions of fractions. The junior grades represent a key learning period for students with respect to fractions as they move beyond part-whole area models to work with sets as well as part-part ratio relationships. This research informed the development of the Math for Teaching Fractions summary document. Rich professional learning opportunities such as collaborative action research support teachers in recognizing the value of deep conceptual understanding. Educators in the project were able to explore new instructional strategies and felt better able to support students and respond to their needs in the moment. Students too were excited to be a part of the project and benefited in their learning as a result of the focus on fractions.